Hello, everyone. This is yet another episode of Career Talks by Welcome Solutions. And in these meetings, we talk with professionals who developed interesting careers and are willing to share their life hacks and valuable tips on how to develop your career with us. And today I have a great pleasure to introduce Fabio Gori. Dr. Fabio first completed his master's degree in mathematics at the University of Pisa in Italy. At that point, he began researching the biomedical field, and he liked it so much that he decided to keep working in experimental sciences. Therefore, he went for a PhD in bioinformatics and data science at Radboud University Nijmegen. The focus of his research was developing computational methods or the analysis of microbial communities. After completing his doctorate, he became a research fellow at the University of Exeter in the UK, where he was using quantitative methods to study antibiotic resistance. He later decided to move to the industry. And so he worked in the German biotech for precision oncology as a bioinformatics data scientist. He moved back to the Netherlands to work as a data scientist at the AI startup Machine to Learn, where he works both on industrial and biomedical projects. Welcome, Fabio. Thank you so much for being with us. And I would like to now hear your story from your own perspective.
Thank you, Natalia. Thank you for inviting me here. Well, that's a good summary of my story. I mean, like I was studying mathematics in Italy, and I really like mathematics. But when I started doing more like applied research, I really felt it was my call. I really felt like this is what I have to do, and I felt like much more, I can say, excited about the thing I was doing. So then I decided to do a PhD, and I decided to do it abroad. And I wanted to try more like, initially in Italy it was more medical research. I wanted to do something a bit more biology. And I ended up in Nijmegen. Yeah, there was this PhD on metagenomics. So you deal with DNA sequences sampling from the community of bacteria. So there were like problems about like finding what bacteria are there, see what was wrong when you acquired the data. And I felt somehow lucky because it was affiliated in machine learning group. I felt in some way lucky because I realized that this DNA sequencing was something that was growing. At that time, the cost of DNA sequencing was dropping at the speed of Moore's law. So like I don't remember exactly the Moore's law to be honest, but like every 2 years it was halving the cost. But then even drop even faster. After a few years, it went even faster. So it was still okay. This is a good place to be, like working with DNA sequencing data. But at the same time, I was in a machine learning group, and I felt like, wow, this is powerful. I mean, I already did a bit of machine learning directly in Italy, but I really felt the good potential. So, okay, in some way, I had the perception that I would find a job after leaving academia, if I left academia. After my PhD, I like that, but I felt like in bioinformatics, there was so much like, let's say, grunt work, like work that you had to code a lot. Sometimes I felt like my mathematical mind was not used enough. And so I decided to do a postdoc involving a bit more of mathematics. And that's why I ended up in Exeter, because traditionally the United Kingdom is the best place for the best country for mathematical biology in Europe. And there it was a combination of bioinformatics, statistical analysis, but also like mathematical modeling of experiments for studying microbial resistance. That's antibiotic resistance. This is a big problem that people are not talking enough, but it's already killing a lot of people, unfortunately. And and then I said like, okay, maybe it's better to, I felt like jumping from country to country to the research is not my life. I want to stabilize more. I want more stability. I don't want to think, okay, where are we going to be in 2 years? Like in which country we're going to be in 2 years. And so I decided to move to the industry and end up in Germany in the biotech German world. That's and there, I changed a couple of jobs, but still it was interesting the first one, well, because it was really felt like both my PhD and my postdoc was somehow the technical skills I acquired in these two jobs were both useful in this new position. So I felt luckily it was really like I tried a transition where my technical skills will be put at use. So I was really happy about that. I felt like I was using them for something. And the interesting at the end that somehow my mathematical background returned to be more valued in the industry than in academia. I guess because you don't find that many people in bioinformatics with a background in mathematics. So whenever there was something kind of like complex or like a certain level of mathematics knowledge, there are not too many, but there are quite some kind of the problem. They're always coming to me. So I was actually using my mathematical skills more than when I was doing a bioinformatician. And that's something I really like. But then I said, okay, I felt also at some point, okay, I felt that Germany wasn't exactly my place, and I really wanted to always wanted to come back to the Netherlands and focus more on the artificial intelligence, or real data science, because in bioinformatics, I was working as a scientist in bioinformatics, but it's the data are so complex and difficult that you spend much more energy on the data preparation, and also the topics is so complex that you really have to understand, that need domain knowledge, and it's much more important. I really wanted to put more mathematical background at use, still in data science role, and to learn more methods. And this job from this point of view was quite good, but I would say perfect, because since it wasn't a startup, I could also like somehow develop the job to fit my skills. And since it's a consulting job, you have to work in different projects with different people, and therefore you're pushed out of your comfort zone and learn new methods, for example, or new skills, new libraries for programming. So that's I really like.
Fantastic. Thank you so much, Fabio, for sharing your story. So if I may start this conversation from asking you, so when was this, when did this final decision happen? So at which point in time specifically you said to yourself, okay, this is it. This is when I have to take the decision to move to industry. Do you remember that day?
Well, I was, yeah, well, it's not exactly one day. It was, I think it's, even at the end of my PhD, I wasn't sure about doing a postdoc. I was thinking, because I said like, I like doing research, but I know that after a certain point, I mean, you stop doing research in academia. And also I felt like what I liked what I was doing more as a job. I mean, it was more bioinformatics, I say. At least my postdoc was, I think in some way I liked it more because it was more mathematical. My PI at the time told me, you can try a postdoc, but after a postdoc you have to take a decision. Otherwise, when you do the transition, it will be harder. So I found this very short postdoc, 2 years, that from an academic point of view, I will advise people not to do 2 years postdoc unless it's really in strong continuation with your PhD. That was not my case, because by the time you start getting ideas, you're at the end of your postdoc. Basically, by moving your field, I really start getting ideas after like 1 year and a half. And since academia is all about ideas, that was not that good. Of course, I mean, there was, as I said, like, the group I was working was a combination like of people doing like system biology, so mathematical modeling for biology, and experimentalist biologists. So nobody was doing the bioinformatics. I could cover it and interface with them and do also a bit of mathematical biology. So it was fine. There was work for me already, but I could not be the one coming up with ideas at the stage. But anyway, in that case, actually for me it was fine. Like the big moment I think was after I did my PhD defense. It was like 6 months, I think, 7 months after I started my postdoctorate, because I came back and I felt like my brain for a month refused to work, because it felt like, okay, you made me do so much work, and then what you get, you get just a piece of paper, you have to keep working even more, maybe. Like I felt like somehow, I felt like by working more, producing more in academia, you increase your likelihood of getting a job, but it doesn't translate into like money that much. I don't know why. I felt like my mind didn't like this translation. And also I felt like this connection between seeing results directly. Like I mean, of course, the things that we're doing were useful. I knew that at least in my case, in one way or another, the things that we're doing were useful. Especially in my postdoctorate, it was, I mean, antibiotic resistance is a very important topic. But on the other hand, you feel like also this idea that you have to make a paper, then submit it, and then waiting for that, you know, it's like you have this kind of like waiting time, anxiety, hoping that you have to rush against the other. It's not like you daily deliver and you daily get some kind of satisfaction. This delaying time also for me was quite stressful. And I wanted something with a more direct impact on reality, let's say. Although what I did already had, but something really more like more up to the point. And I never looked back, honestly. I never looked back. I mean, there are things that I miss about academia, but overall, no. Like, I don't want to go back.
Great. Actually, referring to what you said about not doing research in academic career, I have to say that recently there was some study here in the Netherlands by De Kooijer and colleagues from Rathenau Institute, sorry. And actually they analyzed data from 16,000 PhD graduates that graduated within the last 22 years in the Netherlands. And actually they found out that vast majority of PhD graduates still has jobs, industry jobs that involve research to a certain extent. And it was anything between 60 and like 85%, depending on the field of study. And among those PhDs who hold these jobs, they actually, the mean amount of working time spent on research was also more than 50%. So they not only have jobs that involve research, but they also really spend this time on researching stuff, which is probably much more than if you integrate the research time across PIs in academia. Probably it's much less than 50% research time. So
yeah, that makes sense. Yes.
So in the end, the conclusion was that in industry, researchers do more research than in academia, indeed.
Yeah, it makes sense. Especially if you're a PI, imagine like, it depends a lot on the field. But like, imagine you're like doing biology. I mean, like for now, I mean, things are going to change, I guess, because even academia, people start using robots in lab. But still, like the job of a PhD, lots of the time goes into the lab, and when you become professor, so this time definitely get reduced. If you're doing computational research, like I was doing, is a bit different because you can carry your laptop in an airplane and would still work on your algorithm. So it really, as you said, it really depends on the field. But in general, I think you're right. It's we do more actual research in the industry. Of course, it depends also on your career path. If you go more like becoming senior or C-level in a company, or it depends also on the career path that you take. Another thing that to keep in mind, that's a big issue, but it really still it depends on the field. That when you're doing innovation, there is always like the ghost of obsolescence, of becoming like obsolete. Like what you know could become obsolete. Depends a lot on the field. Depends on what your knowledge somehow. And trying to have a local. I mean, regarding mathematics, my mathematical knowledge doesn't not. I mean, honestly, it doesn't get them much obsolete. So that's a good asset about studying mathematics. But still, like the programming language using now, they're not the one using 10 years ago. Right. When I started my PhD, for sure. Although when I like 8 years ago, maybe, but like the libraries change, so there's continuous innovation. So somehow you have to keep it updated. This takes energy and effort, and so it also depends on the field. I know in some companies, for example, in IT, the standard path is that after a certain point, programmers become managers, for example.
That's indeed. So just quick question about programming then. Are there any other programming languages that are important for today's data science than Python?
Well, I mean, R is still important. Depends also, of course, depends a lot on in the field what you're working on. So in the biotech, still very important because these are bioconductor, these collection of libraries. So that the library is what matters essentially. Although I honestly prefer Python than R. But also there is an emerging language that is Julia. I haven't used it yet, but I'm really tempting on trying to move that. Partially for the speed, but also because of like what I heard about the way you can the way it structured the code, but it has some features that are really, really helpful, that are better than object-oriented, for example, or a pure functional setting. So it's that's one emerging. But for now, Python is still staying, and the great advantage of Python is that it's somehow the best or the second choice in many fields. So wherever you're doing, there is a library, usually it's quite okay. The reason why during my PhD I started with MATLAB, but then I moved to Python because in MATLAB you couldn't really do bioinformatics. And in Python, although it was the beginning, you could definitely do, I mean, there was NumPy, so this computational library. There was no real library for machine learning at the time, but still it was much better. I mean, it could do what it could do in MATLAB. And plus there was already quite robust library for bioinformatics. So I really felt like that by switching to Python, thanks to the libraries that I could do, I could do everything I needed to do. So that's why I stayed there. But you see, like, I mean, as I said, I see this Julia, I think could emerge, like in 5 years, it could really be something.
Okay, well, that's good to know. You know, maybe some viewers who are watching this episode, maybe you will get inspired to check Julia and check what it is. I personally, I never tried Julia, so like I don't feel like I have an opinion here. Okay, great. So could you tell us now a little bit more about the data science market at the moment? Because data science is like a very hot topic, and it's one of the the areas where most PhDs look towards after once they ponder options. So, but definitely there are some groups of jobs or groups of techniques you might be specializing in. Or perhaps a data scientist is supposed to be able to analyze all kinds of data sets. I presume not, right? So, is there any like can you come up with any systematic analysis of how this data science job market looks like?
I would say that the science market is evolving in 3 different directions. At least is what I read in the post, but it was convincing. Somehow, like these generic figures that people like me study from academia is branching in 3 directions. One is the AI researcher, so somebody really like developing new algorithm, prototyping new algorithm. The data engineer, there's somebody more taking care about the deployment of the model, and like all these things evolving around the model, the data. And then something in between, it was like the AI engineer. So somebody that maybe doesn't, at least it's not his core business to make novel, develop new models, but definitely have an understanding, can use the standard models and packages, and it also can bridge that to the deployment somehow. So something in between. I would say that as the time goes by, these libraries are getting more and more evolving. So like I mean, 10 years ago, you had to implement the algorithm yourself. Now there are libraries with already the algorithm implemented. So and this technical part is becoming more and more important because there are more industries switching to AI. And so I would say this central figure, this AI researcher, I would expect to increase, to grow. My figure is quite old school, and I call data scientist because I think my core is more like in modeling the problem, finding the right formulation. So because I'm a background in mathematics and asking the right questions. So in this case, I would say my position is more like I would say interface with the domain expert. So the person talk to the domain expert and try to formulate the problem in a good way, and then there are people who could work downstream. It's evolving. Well, about I'm not really at it in the last couple of months, but I was looking reading about how the pandemic impacted the market. It seemed initially that there was a flexion of job offers, like in every field, but then they came back. They came back because we just adapted. And of course, I mean, my company actually got a project out of coronavirus. So it's so yeah, actually, in some way, like it's even driving more automation and therefore also AI, because usually the artificial intelligence is on top of automation. So I would say that, I mean, unless there are people working in a specific field, that was impacted by the pandemic, like I don't know, companies for web, I mean, doing like in tourism somehow, like I don't know, like air traveling, people doing data science for traveling, data science for a touristic website, unless or Horeca, unless you're really in this specific field that were heavily impacted, I would say that it's still quite good. Actually, initially, some people said there was an increase in jobs in the banking and insurance, and they said this is consistent with what would happen in 2008. When there was the crash at the beginning, people, people had to find a way to save money, and therefore they're used to the analytics. There was not data science that much, was like analytical, people looking at the data. So in Mighty, I would say that we were quite okay. The big question for me, I would say, is like in 5-10 years, what's going to happen between two trends? Like I'm afraid, like I'm always thinking about how are going to get obsolete. So in some way, it might be that like I don't know, for example, deep learning is increasing. Although I also some criticism about deep learning, but let's say, and I know some deep learning, but I'm not really like somebody. I mean, as I said, my core is something else. So maybe like some technology will emerge and that will be just obsolete, or maybe just there will be more people doing data science and therefore it will be less demand, and so the salary will reduce. Or maybe there will be, the demand is so high, there will be more automation. And therefore there will be like less jobs, because I mean, you just need people that somehow to manage existing stuff. I think I'm more favor of the automation. I think the thing is going to happen more likely gradually.
Yeah, actually, that's I share your concerns. I have to say, because indeed, data science as a service is quite expensive, especially in countries like the Netherlands, where labor cost is in general expensive. And indeed, and some data science or machine learning engineering jobs indeed require some specialistic knowledge and experience, but some of them boil down to linear regression and cleaning the data a bit. And I think at least some percentage of these jobs can be automatized, and since it's such a high cost, there is also good incentive to do so. And I worry the same. I mean, I also worry now when I see how many PhD graduates take that road. Then I always wonder at what point will the market get saturated, because there are just more and more people in the space, and potentially the demand will be the demand might be dropping. So indeed, in 10 years, I cannot tell as well. But yeah, that's something, yeah, you cannot really predict, because at the same time, there are more and more different types of machines and different types of algorithms. So who knows, maybe there will be even more jobs in that space. But yeah,
To
I
be
mean,
honest, there was
definitely.
a friend who reached me recently asking like if she wanted to jump to data science. And I told her, why don't you become a project manager? So actually, I'm kind of discouraging people to make the jump, because I think that there is this hype and maybe like they underestimate the level of knowledge. For me also, it's hard to say. So for me, some stuff, it looks easy, but because of my background, maybe for them it's not. And I say, if you really want, so like say project manager is more like, say more stable career, more like more standard career. And it's a common jump. But also, like if you want to data science, I would say do data science. Go to the science that is where your domain expertise is valued, because in this way, like worst case, it will just be with the interface between data science and the domain, and actually will be like make a career out of that. I would say that it can be very bad. So, for example, one of my friends in the end, he was a biologist, but knew to code. He was a bioinformatician also. I mean, he could do bioinformatics, could understand AI. And now he has quite an important position in a pharmaceutical company because of this knowledge. But by background, he's a biologist. Because, for example, what I can see that, especially if you want to grow up more like a higher level in the like executive level, the domain knowledge can matter more than the knowledge of data science. So I would say that something is a skill that you can acquire, and of course it will be valuable, but then probably your safest spot, and also maybe the most valuable, the most lucrative spot, is to be on the connection between the two, between the domain and data science, and more on the domain, or like an executive of a company integrating the two, let's say.
Yeah, very good advice. Thank you for this, Fabio. And could you also tell us a bit more about what do you think are the similarities and differences between data science in academia and in industry?
Well, I think the main difference is that in the academia, although when academia I was really doing some stuff applied, but there is a lot of focus on developing new algorithm. So like you think of a problem, you fight for getting a good accuracy and stuff like that. In the industry, it's all about the data. So and really see like the data is the new asset. You will say that it's new oil, but I can tell you from an antitrust point, from a trust point of view, antitrust point of view, data is the new asset. It's something valuable because with if you have the right data, any team somehow in a certain amount of time could replicate what you, if you get the same data, can replicate what you have. From bad data, there is nothing, there's not that much you can do. I mean, so data is really the valuable thing. And I can tell you, especially when I was more working in the biotech world, a lot of effort there goes into data preparation. So understanding if there is bias, you have to be very, very critical, say paranoid about the data. Is the quantity enough? What are the level of error? But especially the bias. Try to see if there is a bias. Try to think about possible bias and identify them. Because if you have the data, the quantity is enough, and you understand the bias, maybe you can still do something. But the quantity is low, and there is a bias against what you want to do, then there's nothing you can do. So it's very data dependent. So that's the main thing, that the focus is much more about the data, I would say. And also like there you see that the domain knowledge matters. You have to really understand the problem. You have to understand what you want to solve. There is a lot of effort that goes into this translation, this formulation of the problem, talking about the domain expert, asking the right question, making us see the phrase, tell them what is your viewing about the things, to check. Also check what they tell you, because it happens quite, I mean, in the minority case, but still happens that some of their understanding of the problem, when you see it in the data, it doesn't emerge. So there's also often, I mean, you say misconception about the domain expert, not in everything, but on a minority of things that could be relevant. So it's more like having a good understanding of the data, and then you build up something. If you don't have a good understanding of data, you really risk to build something that just predicts the obvious, or something that doesn't generalize. Unfortunately, sometimes the clients really want to push you to go to the model as soon as possible, but then they're going to, I mean, it's sometimes time to convince them. So, and this is the data, but also I think that there's some question that people never ask in academia, or never ask, like they don't ask them much in academia, but are very relevant. For example, imagine you're doing a binary classifier, something classifying between two things. So like imagine, I don't know, between healthy people and sick people. In real life, what you're going to have, most of the classifiers in the literature, they're taught for working on data that are balanced, where the number of sick people and healthy people is the same. But in real life, is not. It's very unbalanced. The sick people likely are a minority of the other, much fewer than the healthy people. But also from the prediction point of view, you have to ask yourself, probably predicting something is actually sick is much valuable than predicting something somebody's healthy. But also the type of mistake you do. So if you if you say that somebody is sick while it actually is healthy, well, you do this mistake. What is the cause of the mistake? And this is hard to say, but at least you can the domain expert cannot tell you probably, but at least they can tell you if it's higher or lower than the opposite mistake. If you classify somebody that is healthy as unhealthy, I mean, these two things. So it's all about I mean, AI always do mistakes, and sometimes will do even badly. So you have to say that often AI is not enough. You have to combine with many computational methods together to compensate with the mistakes, detect these possible mistakes, and say avoid some worst scenario, and also tune these models so that it take into account that these things are predicting at different values. And there are some errors that are more acceptable than other types of errors. And these are things that you don't cover in academia, or usually don't cover in academia.
Right. You have to be much more practical, I guess. And what happens if you do a project for a client and if nothing comes out of the project, really? So in academia, we have that tendency, you know, to torture the data and just mold it as long as it takes so that we have our desired p-values, which is commonly referred to as p-hacking. And just because the overarching goal is to get some statistically significant effect. But what do you do if you do a project in data science for a client and you clearly see that there is nothing in the data? What do you do?
Well, the best thing is to have like a 2 weeks or something like that, a few weeks of like agreed job when you get paid and you have a first look at the data and you get a bit of a feeling that this is enough, it is not enough. Then you never know. If I would be more like in a commercial role, what I would say, I cannot promise it's going to work, but I can promise that it will give you a useful insights about your data. So what I would do, especially what I was doing when I was working, because the fact is that I always had kind of clients or customers in the even academia because I was working with doctors, with biologists. So I was trying to ask them what are the questions they wanted me to answer, and then I was coming up with answers to the question. Sometimes the answers was something they expect, sometimes something they did not expect. Sometimes it was an error in the data, but sometimes it was just that their view was wrong, and that was valuable for them. So my point is that let's say if you integrate your developing AI model with something that is like a exploratory data analysis, so having a better understanding of the data, you may come with information that is valuable for them, and they will find with that. For example, once a client told me, "We want to do this one," we say they think there is a huge amount of money that could be saved, and we look at the data, there wasn't actually. It wasn't. So it was not a failure. We told them that actually, I mean, it was a success if you think about it, because like we saw that the reality was different what they thought. And it's going to happen for sure. Because like, especially unless they're like a very advanced company already doing some data analytics inside, nobody's ever looked at the data. So having just a look at data is a value for that. So I think it's important to keep expectation low and to say that at least you will focus on like telling, let's say, let the data speak for and answer the questions.
Very good advice. Yeah. It's also if you communicate with the client from the very beginning and let them ask the questions, then you provide a report for the questions they suggested. So in either way, whether or not you have some interesting effects, I guess it's always yeah, it is what the clients asked exactly. So okay, well, good to know. I was curious what happens because I thought, you know, that if a client I never worked in this type of job, so I just don't have a feel for what type of expectations do these clients have. But as long as you can manage the expectations, I think yeah, it should be fine. So like my next question would be, so how does your like working week look like typically?
Before or during or now with the pandemic? It's,
Both maybe, because we don't know how much longer the pandemic will take. So maybe this is the new standard.
okay. Well, I actually recently relocated to new house, so also I'm now finding a new normality. Before, I mean, I was living in Amsterdam. Now I'm commuting from Den Haag, and I mean, before pandemic, let's say. So, but this commuting didn't last too much, like 6 months. And in that case, I was coming in the morning. We follow a bit like the agile structure, like so we had this like a stand up. So we give a brief update with what we did the day before, what they're going to do, any blockers, and then we start working on our projects. And usually in my company, I think it's a big advantage. We really collaborate a lot compared to other companies. I see there's much more collaboration, and we have quite a variety of profiles. So that's really a strength. It's really strong that it's not like normally there's just one consultant that works for you and has to take care of everything. In our case, like hiring a team indirectly. So it's really excellent. And sometimes like I of course visit clients, some kind of business meetings, yeah, with potential clients or like following up. And but I would say that it's hard to refine a standard day because sometimes I also now start writing grants, for example. Applying for grants or tenders. So it's actually what I like of my job, the variety somehow that I can swing between like, I don't know, I mean like, I mean, yeah, meetings with clients to writing proposals, updating the website, making presentations, or like actually developing the model. So there, it's hard to pinpoint. With the pandemic, I would say it is quite deep for me. It's the way I handled the time is very different. Initially, I was working so much that was some point the weekend I was just dying. Now I found the method so that I calculated for each chunk of time I work how much breaks I'm gonna take, and at the end I think I'm actually quite efficient because I really like I remove the distraction, because as soon as I start feeling tired, I take a break and have a length break. And so maybe what's gonna happen that I work for a longer time. I mean, I spread my working time on a longer period, but at least I know the performance is better. The main advantage for me for the pandemic is that the silence, because I really felt that in the past also working in noisy environment for me was killing me. I could not concentrate at all. And this silence really simplified my life so much from this point of view. The issue that I had recently, they were working on something dealing with devices. And so, I mean, I was doing more data science part, but I was forced also to do more like the software algorithm part. And there was a bit of an issue because I couldn't ask the colleague, please help me directly. So it's there was a bottleneck. The bottleneck was say that this interaction sometimes it could become difficult. In this case, because it was like a physical constraint, it was the device that was, I couldn't teleport it to Amsterdam to my colleague. But from the other point of view, like sharing the code, I mean, looking the code together, talking, I think in a few weeks we made a transition, and actually I think it's pretty fine.
Actually, I think that this pandemic could, in the long run, change the working patterns for a lot of professionals, because I think most, I mean, I was used to working from home because I used to do that before, but all those who were not, it was actually like a shock, like throwing you into deep water if you have to stop commuting to work and start working from home. But I think after a few months, we all got used to it. And I think many people actually found unexpected pleasure from working from home. And I think after the pandemic, even when it completely ends, I think it will be more common to have that lifestyle to actually bring at least a part of the work home and at least partly work from home. And it's also many companies already, it's actually, there is a big crisis right now on the property rental market, because many companies actually completely resigned from offices just because they realized that they actually don't need them, especially in the data science and all these disciplines that don't really require any like wet labs or anything, you know, that physically is physically there. So I think this situation will change the job market for forever probably, and maybe you will be able to work from home for most of the week after the pandemic, because I think many employers are thinking of reducing their costs by partially or fully moving to working remotely after the pandemic.
There were already some companies working fully remotely, like Elasticsearch. So it already existed, but of course it's a jump that in theory you could do it, but in practice, I mean, you didn't want to take the risk. Now they were forced to take this risk and make this jump. I have to say, after a few months, I also see the downside. So I really miss my colleagues, honestly, like on a personal level, also because I live by myself. So I really like isolated. And so this kind of personal touch, and I really like my colleagues. So that's something I miss. But in my ideal setting would be like spending like 2-3 days in the office and the rest from home, especially like the possibility of having, when you really have one thing to do and you have to focus on that one, you know that you don't need that much interaction with somebody, like, I don't know, working on the same device, especially. In that case, the possibility of working from home really makes a difference. But this is something that I could do, for example, during my postdoctorate. Well, there was some work in the building, so it was super noisy. So for a while, I was working from home. But sometimes, I had quite some freedom at the time, so I could really say, okay, I'm going to work remotely, and it was fine. And like, especially for this concentration, when you need deep focus, it can make the difference if you don't have kids at all.
Mm-hmm. Good point. And actually, coming back to the jobs in data science, I would like to ask you about the whole job search process, because my experience is that, and also many people I know, is that once you go to LinkedIn and start browsing through these data science offers, they all sound the same. So it's always, they're always looking for motivated team player, enthusiastic, etc. And they always offer you the same, like flexibility and friendly team, etc. So it's, I mean, it's almost copy pasted. All these jobs sound the same. So do you have any advice for PhDs interested in this type of jobs in terms of how to choose the right one?
Well, it's hard to say. I mean, it's not that easy because sometimes until you get in, you don't realize the situation. But I would say that I actually see quite some difference in the description. If I think about when I was looking, I remember like, but because I was looking more in the bioinformatic part, I was looking if industry, like before I even like, I don't know, electronics things. So I actually, there's some people like that, I don't know, 2 years ago were really much into deep learning. They only wanted to say, want to do deep learning. Other ones that were really like linear models or logistic regression. So as far as I remember, there was actually quite a variability in the things they were asking. So I think, and that's, I mean, it's, again, it's also like to see the domain really depends. It really depends on the domain. Maybe the one it looks more similar, the one that is like very, let's say, very IT, or let's say very, let's say, pure informatics. The ones I was looking for were all somehow either applied to biology or some applied to something really concrete. So there was always this component that would then change a lot. My first suggestion, if you look for, try to understand if they have the data, because there's people that don't know really how artificial intelligence, data science works, and so they think like you do magic, but they don't realize that how much you're depending on the data. So first, they need to have the data. Second, they need to have like already hopefully clean data, because a lot of effort goes into cleaning, especially with bioinformatics, but not because they're very, very tough data. You really have to like need to design pipelines for processing. It can take weeks. So second, clean data. And third thing, finding people expert that are already there, knowledgeable there, so that you can learn from them. These are the three criteria, in this order, I would say.
All right. And if you think about your job search process, like if you think all the way back to your academic career, is there anything that you would do differently?
Yeah, I would do. I will start searching for a job sooner. I think like after a few months of my post, when I felt like this is, I mean, I don't want to go on with the academia, I already started looking for a job, for sure. And then then it's hard to say what else. Maybe curate a bit more my CV. Also realize that I mean, I was very like I tended to super prepare to the interview, but actually like thinking that is your only chance to do something is very, very bad for your performance. So obviously there will be a second chance. Try to be more relaxed, let's say, and that are the main things. Like check your CV well, and also like don't be scared about the advertisement you see. Sometimes they're like asking things that are clearly impossible. In the end, you don't need to be you don't need to match everything. You just need to be the most matching among the applicants. So like be bold. From this point of view, you can be bold. So you can try applying. So yeah, what I would say be my suggestions to. Like I would say that, for example, what I think that it made me took a while to move the transition. Yeah, I was very selective, honestly, because I was looking for something combining on bioinformatics, and there wasn't that much bioinformatics at the time in Europe, outside the UK. But it's also a thing that there was something in my CV that didn't look nice, and so that's probably the reason why. That's it.
Yeah, actually, you raised a very important point here, because as you said, you don't have to be perfect, you have to be less imperfect than others. And actually, many people get intimidated when they see, for instance, how many applicants applied through LinkedIn, because you can see these numbers, and they're like, oh man, it's already 100 people, I have no chance. But what they don't realize is that among these 100 people, 50 or 60% was completely random, or just people who just shoot their resumes everywhere. and among the remaining half, at least half of those resumes and motivational letters were just drafted, not very good quality. And just when you look at the numbers, then if you do it well, you still have a fine chance of getting through at least the first round and then have a chance to present yourself. So yeah, these numbers like don't really tell the truth about your chances. So it's,
I agree.
yeah, it's good to take chances and
And
then look at this.
there are two things I would like to say. Like probably if you're applying to a big company, you should do something that I don't do actually. Well, yeah, I'm not applying anything now. But like take your CV and make it in a format that is like a Word document, something that can easily be extracted, because there's also AI for human resources. It's a growing field, and the more like fancy. So mine is a very fancy, make with LaTeX. It looks very nice, but then it's hard for this kind of argument to extract the text. So make something that that in this big company, the text will be extracted. That's a very basic, but it could make it different. But also remember, if you're not selected, doesn't mean that you're bad. There's so many reasons why it was. I mean, I can tell in this one because I also was on the other side. When I was in the biotech, I was also interviewing people in both of my jobs. So I can tell you that the selection can depend on so many things. Maybe like you're an excellent and you're very good in what you're doing, but they're asking different set of skills. So don't be afraid. I mean, don't feel let down. It's not an exam. It's different. It's more like looking for a match, and also that you're in power of choosing the match. That also matters.
Yeah, that's very interesting. I didn't. I skipped that detail about you, that you also recruited in your previous job. So could you tell us a little bit more about that? And also, from your experience as a recruiter, well, as a part of the recruiting team, can you name some deal breakers, some things that made that negative, made you reject a candidate?
This is not a question because it's also hard to detach this one for the people. But if I think about in the first job, what we saw, for example, well, there were some like it was bioinformatics. There were some biologists who just did somehow start using the computer, so they thought they were bioinformatician, but it's really not. And there is, oh my, if it is a postdoc, I could be a professor. I was really thinking like, wow, how these people can be like in MBL, and I don't know. Before I would have worked in MBL as well. So like you find like some people that are overestimate. In some cases, they don't really understand what they're doing. In other cases, there are just people. There were people very far from the domain that know nothing about bioinformatics or anything. Sometimes I had the feeling that somebody was discarded because it was a bit too, because like the team was more biologist oriented and it was more like computational. So it really depends. Sometimes it's about like, sometimes like you might have to, in this case was an interdisciplinary one. So it could be hard to convince some, yet the ideal thing is to know the audience, to see if they, on which of the two sides are prevailing, and showing that you're complementary to them, but you're also you're convincing on their point of view. I would say my first interview in this first company was really, really hard. So yeah, I had to be really prepared on what I had to make a presentation. One mistake that I was doing that's important, I was giving very scientific presentation. Where I had to, the best thing is to do a mix of about yourself and something scientific. Something scientific to show what you're doing, and then they will ask you a question about it. But something about yourself, because you're not just your job, you're more than that. So you have to do something in between. And so yeah, they asked me actually quite tough questions. So it's was pretty interesting. So to prepare on what you're presenting, prepare to be asked question out of your comfort zone. What I saw, for example, when I was recruiting the second time in the company I left, I was kind of recruiting my replacement. And in this case, I was the one asking the nasty question. But I really felt sometimes my boss was falling for a guy that for me was a total fraud. But just because it was my boss was like a bioinformatician coming from biology, so I didn't realize that what this guy was talking about. I don't know, neural networks. It was something so obvious and trivial that everybody could say with the minimum knowledge. So you could, that also can play your role. Like if somebody is lacking, if you do a disciplinary role and the people are in a certain mostly focused on certain direction, you can claim that you know more stuff on the other one and they will not find it out. So that's also playing your role. But I would say be prepared on what you're doing. Ask yourself, if you're presenting a work, ask yourself critical questions about what you've done. Try to think about the question you might get. And don't be afraid to say no, yes. I mean, like, it depends also the culture, but like, I know sometimes some of my colleagues were frustrated by some candidate because we're in Germany and they were not giving direct answer. But they say, like, just say, as I said, it's more about matching. So you shouldn't think about like what is the right answer. You should think about like what is the answer that reflects myself somehow. Being true. I mean, if you're not saying the truth, then and then you're hired, then you have to mesh a lie, and it can be tough. I mean, so that's in a nutshell. The other thing I could add is that yeah, like as I said, is a double match. Yeah, something that I can tell you play very, very badly. People that you ask question and you really feel that they don't know what they're doing. I remember one candidate. I just asked something. I just had a question. She told me something like, it was like we just met. I don't know. It was very basic. In fact, she didn't even listen to me. And so then ask a question, technical one, but it wasn't tough. It was just for understanding better. It was like, yeah, more like for trying to how if I was understanding what she was saying. And then she replied something nonsense. So it's so listen to what they ask you. Let's say.
Maybe it might have been partially due to stress as well, because sometimes you have this blank wall in front of your eyes all of a sudden in the interview.
Yeah, but in that case, you say, sorry, maybe like you can say, could you repeat your question? Let me think about it, but not give an answer doesn't make sense. So like silence is better than, not replying is better than a wrong reply.
Okay, well, that's also a lesson. That's a good one. Actually, interesting because yeah, I thought that silence is not the very best thing. So you have to find some feeling.
No, you have to feel like also what they say. If you don't know something, should they say that I think it depends on the culture. So in some culture, very direct, the Dutch one, you might say, I don't know this one. But then you can come up with some compensation. The more Anglo-Saxon culture, we should directly come up with the compensation. But something that is true, you like, but in this case, it was like a technical question. So it's not something like is my understanding of this thing correct? And then you should say like yes or no, like that there is no alternative, you can ask somebody to rephrase the question, but coming up with an answer that is neither a yes nor a no, and that has nothing to do with the question, that does not play well in your direction.
Mm-hmm. Okay, so you already gave us plenty of information and plenty of great advice. The last thing I would like to ask you is what would you advise to all those people who are thinking about data science and it sounds very interesting for them, but they didn't requalify for this field yet, and they are thinking of taking online courses or maybe taking additional studies to start data science jobs? And what would you advise them? So which direction is actually worth to go today? And is it even actually at this point when we were talking about this, the amount of data scientists and the supply of data scientists on the market is growing so fast, is it still a good idea to start?
Well, as I said, when a friend asked me, she told me she wanted to move. She's an epidemiologist, told me like, just become a product manager. Maybe because all the people with the background in biology or like biomedical things I know, they end up doing product manager. But I can say that having a bit of education in data science is very helpful, even if you don't do data scientist, because it then allows you to have an understanding of things going on. So the main problem that I had when I was in this biotech world is that these people that I was dealing with had no concept with that automation. Because like saying bioinformatics, like saying this, in something is like some AI comes after the automation. And there is a lot of stuff to do still in automation. And I would say that it's more important to understand like these IT things, the computational programming works and so, because this is valuable wherever direction you're going to do. And if you want to, so even if you become a project manager, for example, because I tell you, people, I deal with project manager, they know, and it was a big limitation. I would say that if you really want to move to data science, I'm not discouraged. I mean, learning more data science is helpful anyway. As I said, it's something that, because it will combine with your skill. If you really want to, I would say try to look for, if you're like a PhD, try to look for papers of combining your domain expertise, where people use data science, AI, machine learning on things related to your domain expertise. That's the best thing. Because your domain expertise is your main asset. If you can combine it with the science, that is fantastic. But look for that. Also because what I saw is that sometimes like the lack of knowledge in methods could be compensated by knowledge in domain. So my transition, if you really want to do the transition, go through something as close as possible to your domain. And even for learning, a good way is to look at papers when they use these methods on your domain.
Okay, thank you so much, Fabio. Thank you so much for all your insights and for being with us today. And for everyone who is watching this episode, I'd like to mention that if you guys would like to get more of this content, then please subscribe to this channel, and of course leave us any comments and questions you might have, and we will diligently answer all of them. Thank you so much, and till next time.